to go even deeper into that topic, we have Jean-Marc who's here, who may or may not know Jessica, and work in that same world. So Jean-Marc is going to go a bit deeper on that same topic. Jean-Marc, thank you so much for coming. And because we're at time, I'm going to turn it right over to you.
So this is going to be about immersive audio. It's going to be towards the end. I'm going to try to make a connection with what Jessica just presented. Thank you, Jessica, for the audio examples, because I don't have any, and this will be a great way to make the connection. The overall goal is to think about, to explore an upcoming generation of immersive audio formats that does not exist yet, but discuss limitations that we are facing today and what we could envision as next steps. So I'll start with, the reason why I feel comfortable talking about that is because I've seen this problem from various angles, gaming versus recording, linear audio versus interactive audio, but also consumer versus content creation. So I'm going to share with you what I'm thinking about this. At this point, I work as a consultant for a company called Virtuel. The E is special. It should be an A, but I'm French, so this is why the first word has an E here before the L. So let's consider a few questions. What if we could, when we're sharing a music experience, like say maybe a concert virtually in VR, what if we could do it in a manner, do that so that not only the visuals are spatialized, but also the sound appears to come from where we see the elements. Today, this is not the best example graphically, but imagine a VR experience of a concert of maybe hip-hop artist. You can see the hip-hop artist apparently singing, but the sound is the traditional stereo sound that you would hear if you're listening to this song on Spotify, for instance. What if we could, when we produce a piece of music, do it in such a way that the end user can interact with it and make some changes, boost some sounds, travel around, maybe navigate in the music, maybe remix it. So this is an example of an application that has actually the audio shake technology under it, I believe. It's a DJ app that you can run on an iPad, but you can actually, while you're mixing, change the volume of various instruments. Or let's consider a movie soundtrack where in the future it's going to be possible to send a movie soundtrack to a consumer in such a way that while they're playing, the language changes. And we just had examples of separating the dialogues from the rest. With artificial intelligence, it's going to be possible to actually, without changing the voice of the actor, have them speak a different language. Can we do that today? What would it take to make this kind of thing happen? So that's going to be the kind of questions I'm starting from. I'm going to introduce some ideas on how immersive audio formats could evolve in the situation where it's a new piece of content, like a new recording or a new soundtrack or a new immersive VR experience, or it's an existing piece of content. And in that case, how would we leverage source separation technology to try to take advantage of that? Because there's a lot of content that's out there already that if we could do a good job with it, such as what Jessica presented, that would be very exciting. To go over this, I'm going to start with a very concrete example of a music event that we would like to share in, let's say, a VR experience. And end the talk with a broader perspective, which is, okay, if it's just not a virtual music event, but a movie soundtrack or any of the other examples I cited, is there a solution that would also work for that? So I'll start with talking a little bit about the situation of immersive audio formats today, in a situation where we're recording a piece of music or a movie soundtracks. I'll talk about then the virtual event situation where highlight the fact that it's actually, even though it is maybe a music experience, the fact that we would like the end user or the consumer to interact with it means that today we're using a vastly different workflow and tool chain to create that experience. That's kind of sad. It would be nice if somebody could create a piece of music or content and say, hey, I'd like the end user, for me as the creator, I'd like the end user to be able to remix my content. And today we can't do that. We have to actually leverage different kind of tools to create that kind of content. So that will take me to the proposing the concept of acoustic objects as a future direction to consider for immersive audio formats, and enabling consumer interaction or navigation with the content, even if it's recorded content, but also enabling things like on-the-fly automatic translation, like the example I just cited. And we can do it. What we would like in this case is make it sound as if, okay, maybe it's not the original version, maybe it's not, I'm listening to it not in the country where the content was made, but it sounds to me as if it's the same quality as the original version of that soundtrack. What would that take? And I will end this talk with a proposal, an idea that is backward compatible, but is an extension of the current formats that we could also apply to existing content if we leverage source separation technology like Jessica just presented. So let's start with recorded music. I'm going to check the time. Okay. So typically, when we're recording music, when we're producing a piece of recorded music, we use digital audio workstation tools where various kind of effects can be plugged into the signal flow. Here I'm illustrating 3 types of effects. Insert effects, which would be every single source, like maybe one instrument, has certain effects that we apply to it, like equalization, for instance. Another type of effect are auxiliary effects. That would be very often, that would be reverberation that we add as an extension, but where it is shared. This effect is shared. It could be shared between multiple sound sources. Here, the red line is showing the addition of reverberation to just the first source. And then finally, we could have effects that we apply to the final mix. So the situation here is that we're going to talk a little bit about the reverberation in this situation and new formats. So in new formats, one thing that happened about 10 years ago is that new formats such as Dolby Atmos, which is now very popular, were created and became initially proposed for movie soundtracks, and now are available for music. About 5 years ago, that became something you can also apply reliably with predictable results for music. And what's happening, if I can go back one, I know how to go back one. Now the blue format, the master format, is a format that doesn't have to be decided at the moment the content is created. Okay, so the consumer can say, hey, I have my loudspeakers set up, for instance, this way. And the decoder on the consumer end is going to basically read the content, be aware of the configuration that the user is listening in, and do a mix especially for that situation. However, I was showing previously the reverberation, which is the sounds that are intended to be perceived as coming from everywhere. The decoder on the consumer end is going to have to treat them separately, and it's going to have to receive them separately. So the result is that typically in those formats, although it's wonderful that now it's possible to create content without presuming what speaker configuration the user is going to use, we do have to do something like this, which is we transmit to the end user separately each of what we now call audio objects. But separately, we're going to have to transmit also a bunch of channels that contain the reverberation because we need those to be coming from all around. So let's consider the situation where there's more than one sound at a time. If we had to send in a different set of maybe 8 channels, so for instance, the reverb for character 1, character 2, plus sound effects, etc., we would have a lot of channels to send, and we can't do it in practice. So typically, we transmit the channels for the reverb where there's a mix of all the sounds. And if we wanted to separate them out, we would have to use source separation inside that thing that's now called the bed very often. So we end up with a situation which is quite limited. That means that we are not able to allow the end user to, for instance, replace one of the objects by another object at playback time. So I'm going to take the example of a physical, of a music event, of a concert, and compare what happens when we go attend physically a concert, and we try, later I'll try to consider the problem of replicating that in a virtual experience, maybe in virtual reality. So here, the physical event, that we have situations where we naturally experience the sound without, there might be loudspeakers here on this first picture. There are loudspeakers so that the musicians can hear themselves, but possibly there are no loudspeakers going to the audience, and the audience is just getting an acoustic experience of this live event. There could be other situations like this one where we're using loudspeakers to actually amplify the sound, and traditionally they're just two big loudspeakers in front. But more recently, something that shows that it matters commercially is that for those who went to Las Vegas recently, you may have had the opportunity to visit the Sphere. And what's happening there is that there's a very sophisticated sound system that could only be, the kind of investment that was made to create that could only be motivated or justified by realizing that immersive sound is very important for people to truly enjoy the experience. Because delivering an immersive video experience, okay, fine, we can do that in an IMAX theater, for instance, but in this case, we don't see them, but there's a huge number of loudspeakers that are embedded in this design so that the sound can be perceived as coming from anywhere around us. So let's imagine that now we have we would like to replicate this experience in a virtual reality situation. What we would be able to do, first of all, the tools to generate the experience, to create it, would have to be different. They would have to be the kind of tools that you use when you develop a game experience. So they wouldn't be the digital audio workstation. So first of all, we have this split in terms of workflow. Typically, what would happen is that the technology is there to generate immersive graphics, but the sound that would accompany the experience, as I mentioned earlier, would still be the conventional stereo sound. So there's something wrong with the formats we're using to generate these kinds of applications. If we could overcome that limitation, we could create this kind of experience where, for instance, some of the instruments would be remote, a remote singer participating together in real time with real-time musicians on stage. Well, I'm watching with VR this experience from home. I don't need to get on a plane to go to that experience. And that singer, who in this case is a lead singer, is a lady, does not have to go to the venue either. In principle, in the future, we would be able to do this, but we would have to overcome a number of limitations. If we go back to creating the music, and we consider the time when the mix was created using a DAW, all of the sounds were individually available to the person creating the content. It's only when we stopped producing and we said, I'm done, that we exported from the creation environment, and then we baked everything. We baked the reverb into what I called the bed previously. So now the end user who receives this content is no longer able to separate things out, even though initially they were separate. Let's compare that with, in this case, the tool I showed is a tool made by a French company called Flux, and it's called Spat Revolution. It's based on a tool made at ERCAM, which is a place where I worked in the past. And what I'm showing here is that there was, for each one of the instruments or the objects, a number of parameters were available before the export. If we had been able to keep them and send them to the consumer could do a lot of interesting things with the content. And it turns out that in a game authoring environment, the parameters are of a very similar nature. In other words, the renderer that would need to be provided to the consumer is in fact similar. I can show it here, which is imagine a workflow from content creation to rendering on the consumer end. The renderer, whether it's a recorded piece of content or a game content, it's actually doing the same kind of job. It's doing a real-time mix. And if we were able to send it the same parameters that we use when we're producing the content, it would be able to render that too on the consumer end, to redo the mix, essentially. So what that suggests is the notion that I'm calling acoustic objects, where we would extend the formats that we have today so that the metadata that comes with the objects, that each object has some metadata that describe how to present it to the end user. If this metadata also carried reverberation information, for instance, then the end on the consumer end, the renderer would be able to say, okay, I can render that reverb and make it sound like you told me, because it's coming via the content. And so we just need a slightly more powerful renderer than the renderer we use today to, for instance, play Dolby Atmos. Oh, by the way, I intend to share these slides. I didn't check with the organizers whether I would love to make these slides available after the session if it's possible, but I forgot to ask you if you're going to permit that. Otherwise, you can reach me via LinkedIn or anyway, because I'll have a slightly updated version of this available. So going back to metadata, the metadata would allow the consumer to interact with the content. And we could define that standard in such a way that there are various levels of interaction. The first level would be, for instance, be able to let the consumer passively experience this content without moving around. Another possibility would be, the next level would be where the consumer is able to replace certain instruments, for instance, in the mix, or substitute the language or remix the content, as I showed earlier with the algorithm DJ app. And finally, not finally, one additional level is, what about allowing the consumer to navigate in the content and get closer to certain instruments or further or around, walk around, etc. So that would be an additional level that we can also update, enable via the metadata in a very similar manner as in the game. And finally, what about if we're presenting this content in such a manner that the objects appear they are visible in maybe augmented reality, and everything seems to be happening in the room where we are. That would be where we transmit, but we have the option of replacing the acoustic space where this experience happens. So I'm going to check the time. Do I have a bit more time? Yes. 10 minutes, okay. Okay, so I'd like to keep some time for discussion. So I'll wrap up by talking a little bit about why we would do all this. Why would we create this new kind of, extend the formats we have today and potentially take existing content and use source separation technology to give it, to endow the content with that kind of nature of what I'm calling here acoustic objects. So in an ideal world, the consumer would appreciate the content. And if the consumer likes what they hear, that's going to encourage adoption and the creation of more content. What would that take? So first, we would want, regardless of the application, whether it's interactive or linear, whether it's a game or music, we would like the experience to be consistent, to be compatible, so that we would like the consumer to have a device that does not need to know whether it's playing a game or a piece of music or a movie. And we would like the experience of the consumer to be predictable such that based on just the way they experience the real world, actually, if the content is generated digitally, it sounds consistent with what they're used to. So cognitively, it's not an extra effort to appreciate, for instance, the music. We would like to be able to personalize the content so that if, for instance, you have some hearing loss, well, the rendering system can take that into account and adjust the content such that you can fully appreciate it as if you didn't have that hearing loss, for instance. Or that it could be your preference. Maybe you prefer the dialogue to be a little louder, for instance. And finally, I mentioned the case where we would like the device to be able to take advantage of knowing some aspects, some qualities of the room where you're playing. And all of this would be possible, it would be possible if the experience is an interactive audio experience, like a game or VR. And we would like to make this possible also if the content is, let's say, music that was recorded even in the 70s, even a long time ago. And to make this possible, to make this, I think, a virtuous situation, we would like to make it so that it's very easy to create content that would be appreciated in that way by a consumer. And what would that take? It would be having workflows that are very efficient so that you can easily create that kind of content. It would also mean that whether the content is, has some physical basis for the acoustics that you're generating or purely aesthetic, that it doesn't matter, that the same format can be used and the same distribution ecosystem can be used. And finally, you would like to be able to offer solutions so that it's as easy to do it for a linear experience or an interactive experience. So to conclude, we would like to have all the devices to be interoperable because they all speak the same language, much like today when you make a graphic sound cards, you can make it compatible with OpenGL, it just plays. And it need to know whether the content was generated is a game or a movie or another form of video content. So that would be essentially trying to have a format that allows any vendor to make the playback system. We would want the presentation to be immersive and the quality to be consistent regardless of the position of the sound elements. We would like the experience when you're listening on headphones to be as convincing as when you're listening on loudspeakers. So that's not a topic for my talk today, but that's another challenge that needs to be addressed. And we're making some progress on that. And when we have this situation, that means that someone can play any content. And all we have left to do is to make it easy to create the content, as I mentioned earlier. So that means a wide range of content that just plays without the device knowing where it comes from. I mentioned serving both audio experience, whether they're artistically motivated or physics-driven. And I mentioned also serving experience that are either linear or nonlinear, nonlinear meaning interactive. With this situation, we have, with a very limited extension, which is just this notion of acoustic objects, we now have the ability to allow the consumer to interact in a very rich way with the content. And that'll be my conclusion. I'll just mention that if it's catalog content that already exists, all of this, we could do it, but leveraging source separation technology. And that'll be my conclusion. Thank you. I still have a few minutes. I think selectively, so that we don't do everything at once. We could say some of the objects, I'm not going to bake them into the bed. I'm just going to add some metadata so that the reverb, for instance, can be, if it's dialogue, you could, if you just on that object, rather than putting its reverb in the bed, you keep it separate and you you allow for generation with metadata at the consumer end, you have a more powerful situation.
And I think the second part of what you said was, rather than defining objects as a vector size and waveform, you actually build a 3D space of objects so that you can move throughout. Yeah, that's what
The creator would have this option, but that's why I propose several levels of metadata, because at the first level, it can be very limited. That depends on how much interaction you want to allow the end user to have. So because of that, I think it's useful to allow various levels from the get-go when we build something like this. Thank you.
About 3 minutes for questions.
Yeah, on that is the mixing sort of part of the creative process for the artist, whoever's creating it, right? So if the consumer decides, consumer decides to take out the background noise entirely, record voice, then they're changing sort of the experience of maybe what they want to receive, or the artist wants the audience to receive, or how they want to sort of experience the subtext by what's happening in atmospheric sound, those kinds of things. Doesn't that sort of get lost?
I think it's important for the content creator to decide whether they want that or not. What in the situation we have today, either the content says it's going to be baked and there's only going to be one way to listen to my music, or the content creator is going to be able to say, you can navigate inside this virtual concert if you want, you can remix it, but we only have these two extremes. And I think what I'm proposing here is that if the content creator wants to offer an intermediate level of interaction to the consumer, then they would have this option.
One more back.
So one of my arguments that the sound system in audio has been invented. So I want to know that what's the big difference between this immersive and the surrounding systems? So is it just the number of speakers, or there are some other elements?
The way I understand it is that it comes from a desire from the creator of the experience, where it's the understanding that the experience is richer and more valuable to the end user. That's what I try to illustrate, for instance, with concerts where there are loudspeakers all around. There is this assumption that I think we can now make, which is that we've seen that in movie theaters as well. In practice, we put more loudspeakers, but they're just a means to deliver a more immersive or more engaging experience to the end user. Does that answer the question?
Seems like most of those things really just about what a sophisticated big off planet machines they buy a TV and they buy a sound bar that beat and then what's the audio is so now sounds but for a lot of people leave their content on phones with earbuds and it seems like it's kind of developing the way of so that I'm like starting to
I would agree that when we consider future formats, immersive audio itself to create an immersive experience maybe is not a sufficient motivation, but if we add the ability to personalize the language or to remedy hearing loss, etc., we have extra motivations, I think, to push the formats beyond where they are today. But I would agree that immersive audio alone, even though that's the title of my thought. Yeah. I think
You'd be surprised what's coming to consumers every week. It seems they're getting the technology, whether they're looking to buy it or not. It's getting handed to them. So Jean-Marc, thank you so much.
Welcome. Thank you.